is December 5th. Right, today is December 2nd, right? So Wednesday, right, December 5th, Saturday, right, from 8 to 10, okay, 8 a.m. to 10 a.m. to our final. So please do not miss the final because it will be very difficult for you to make the final, right? If you miss the final, then you have to provide the documentation to show why you missed the final. If you have medical emergency or family emergency, unless you have medical emergency or family emergency, right? Otherwise, it will be very difficult for you to make the final, okay? Unless you have this kind of documentation to show that you have medical family emergency, right? Now let's continue with our final exam review, right? So today is the last day, don't forget, okay? Tomorrow we don't have a class, okay? So let me share the screen with you, okay? We're almost finished, right? Except a few problems left, okay? A few problems left. Okay, so allow me to share the screen with you.
William just asked what calculators are allowed on the exam.
Okay.
William
I'm sorry,
T
what?
asked William T, he asked what calculators are allowed on the exam in the chat.
Oh, just regular calculator, no graphing calculator, just regular calculator. William, just regular calculator, scientific calculator, but no graphing facilities.
As long as a calculator that don't graph, okay.
Yeah, that's fine. That's fine. Okay.
Okay.
As long as the graph has no, as long as the calculator has no graphing facility, that'll be fine. Okay. Any calculator will be fine as long as you can do sine, cosine, so on and so forth. Right. Some calculator cannot do sine, cosine. Right. But unless you have, but if you have a calculator that can do sine, cosine, log function, or that's fine. Right. That's fine. Okay. Now, actually, every answer should be exact, right? So there'll be no approximation unless the problem asks you to approximate, right? So you got to remember, okay? Hey. Okay, so let's take a look at the phi, okay? The phi. Okay, that's phi, right? So that's the so-called final exam review. The file was sent to you, right? So you got to do it by yourself, but I try to help you to go over every problem one by one, right? Actually, you got to do it by yourself, right? It's your work, right? But, okay. Now remember, we had to, what? We had to finish number 7. Yes or no? Look at your notes from yesterday. Have we finished number 7 yet or no?
I don't think so.
We did not finish. We did not get to
Okay,
7.
so let's. But we have finished the number 6, right?
Yes.
Look at your notes. We have finished it. Yes or no?
Yes.
Yes. Okay, so let's start with number 7. Okay, so find f prime 2 for this function. So this function is what? Naturally, you have to find the derivative by using what rule here? Quotient rule, right? Because it's a function over another function. So easy to find derivative, okay? Easy to find derivative by using the quotient rule, right? So how to find it? Right? Denominator square, right? We have x fourth. Please copy the answer, okay? Because this is not on the file, right? You have only answer key, but no, right? x4 plus x squared. Now, this derivative for x cubed, right? times x4 plus x, okay, by using the famous quotient rule, right? Minus x4 minus 1 times the derivative for these, which is 4x cubed plus 1, right? Okay, so, right? Derivative of f prime g minus fg prime, right? So this is the quotient rule, right? 4x cubed plus 1, right? Now you can put 2 inside to evaluate that, right? We have to evaluate the derivative at 2. So put 2 inside. Okay, it's easy. Right? Put 2 inside and 2 find the answer. Right? Replace x by 2, find the answer. This is so easy, right? So please find it by yourself. Okay? This is just pure arithmetic. Okay, now let's do number 8. Let's do number 8. Put 2 inside, you can get the answer. You can use hand, right? You don't have to use a calculator because this is not very complicated. Now you have to use, this is very important, okay? You have to use implicit differentiation to find this is what? This is nothing but y prime, the derivative, right? So let's use y prime because it's easy to write, right? Easy to write. Now, how can we find the derivative for this function? Here, you cannot solve y in terms of x. It's very complicated, right? But still, we can find derivative by using implicit differentiation method. So you take the derivative with respect to x on either side, okay? So you have y prime, right? Y prime. Here, use x times cosine y. So you have to use the product rule, right? So x derivative is 1 plus 1 times cosine y plus x times the derivative for the cosine y with respect to x. Here you have to use the chain rule, right? Cosine y derivative is negative sine y. And then times y prime by using the chain rule, okay? So this is the left side. The right side, you have to what? You have to use the product rule once again because it's x squared times y, right? X squared derivative 2x times y plus x squared times y prime. Okay? So next step is to solve for what? Y prime. That's the next step, right? Solve for y prime. Don't forget that, okay? Now easy to solve. You put a y prime term on one side, every other term on the next side. On the other side, so you have y prime here, right? You have y prime here, minus x sine y. Times minus x squared y prime. Sorry, sine y prime. I forgot y prime here. Okay, times y prime. Minus x squared y prime. Right? You shift y, whenever you have y prime term, you shift to the left side, right? And move z to the right side, change the sign, right? It's 2xy minus cosine y, okay? This is negative x sine y times y prime minus x squared y prime. Now factor out the y prime, then divide, right? You can get the answer. So let me write down the answer. So y prime, where is the, here, y prime is equal to 2xy minus cosine y. Please copy the answer, okay? Copy your work. Please write down my work, okay? That should be your work, right? But I have done this for you because I want to help you, okay? So 2x y minus cosine y, here you have 1 minus x sine y minus x squared. So we have finished. Okay, that's the derivative of y with respect to x. dy over dx, or just write y prime, right? So 2xy minus cosine y over 1 minus x sine y minus x squared. That's the answer. Okay, you cannot simplify further, right? That's the answer for the implicit differentiation. Okay, implicit. Any question? Right? So that's the answer. Okay, so we have found the dy over dx by using so-called implicit differentiation method. All right? So we have finished. Let me erase these. Okay, we don't need these anymore. Right? Okay, please copy the answer. If you don't know how to do it, you got to copy, show your work. Right? All this work has been shown on the screen. Right? You got to copy it if you don't know how to solve it. Right, so we have finished the problem. Now let's take a look at the answer in the file. Right, same answer, right? 2xy minus cosine y over 1 minus x sine y minus x squared. Same answer. See, right? Same answer. Right, you got to learn how to handle these, right? Same answer. We have finished implicit differentiation review. Okay, what's next? Number 9 is find number 9. Okay, we have done number 8, right? Implicit differentiation. Let's do number 9. Okay, so number 9. What's number 9? You have to find the global maximum, global minimum of each function on the interval negative 2, 2. So how can we find it? Right? That's you got to find it. So how can we find it? By using what? By using the derivative. Let's get derivative equal to 0, solve for all the critical number, then compare this with two endpoints, right? How can we find derivative? Tell me, how can we find derivative? By using what rule here? What to find derivative? Tell me, what rule you want to use for the derivative for this function?
The quotient rule.
Right, same rule, right? Thank you. Got to know quotient rule is so important in calculus, right? So this is x squared plus 1 squared. Right, that's the denominator. Now numerator is this f prime times g. So this derivative is 3 times x squared plus 1. Minus fg prime, f is 3x minus 4. Times g prime, which is 2x. Okay, so let that equal to 0, right? Solve for all the possible critical numbers. Now let's solve it. How can we solve it? That means that what? The numerator should be equal to 0, right? So this means that distribute 3x squared plus 3. Here you distribute, right? 2x times 3x is 6x squared, negative, right? Negative 6x squared. This is positive ax, right? Equal to 0. Okay? It times over, right? If the fraction equal to 0, the numerator will be 0, right? You see square plus 3x, this is ax, okay? Now here to simplify, please solve this. This is a quadratic equation, you have a formula. right? To solve for the quadratic equation. So shift everything to the right side, you will have, this is negative 3x squared, right? So this becomes, shift everything times negative 1, okay? So you have 3x squared minus ax. Okay, so this is negative 3x squared plus 3x squared minus ax minus equal to 0. So now please factor these. How can we factor? Otherwise, you have to use quadratic formula. But here we can factor actually. How can we factor? How can we factor 3x squared minus x minus 3? Please try to factor. Because it's easier if you can factor, right? Please factor. What's the answer?
Ain't the top should be negative 3x to the second power?
Let me see. 3x squared. What do you mean second power? I don't understand.
I think it's supposed to be like negative 3x to the second power.
No, that's right. Yeah, 3x squared, right. 3x squared plus 3 minus 2x times 3x is negative 6 squared. You see negative 4 times 2x, negative x. You have the negative sign, 8x. So move everything to the right side. It's, you see negative 3x squared, become positive 3x squared, change the sign, right? So you have these. That's right. Now please factor these. Can you factor these?
Is it 3x plus 1 and x
These
minus
are
3?
simple. I'm sorry, what?
3x plus 1, x minus
3x?
3.
Thank you. Let's verify this is the right answer. Okay, you got to verify it. So 3x times x is 3x squared. You see negative 9x plus x will be negative ax. One times perfect. This is the right answer. They have two roots, right? X equal to negative 1/3 and 3, right? Two roots. Now, what's our interval? Our interval is negative to 2, right? Interval, right? Because the interval is from negative to 2. 3 is outside, so you don't have to worry about this number. Because 3 is outside this interval, right? Now you have to what? You have to find a value for these two, find a value for f at negative 1/3. Because this is only a critical number inside this interval, right? Because 3 is outside, you don't have to worry about it. You have to evaluate f value at negative 1/3 and then compare with the value f at two endpoints, negative 2 and f2. Okay, so you have to evaluate f at negative 1/3. So negative 1/3 inside this function. And for negative 2 inside the function, and for 2 inside the function, compare which one largest is your maximum value, global maximum value, which one is smallest is the global minimum value. Okay? This is pure algebra. I will ask you to finish this part. Okay? Finishing this part. Right? The major work has been done. Now all you have to do what? Just find the f value at these numbers, right? And then compare which one largest, which one smallest. The largest one will be a global maximum. The smallest one will be a global minimum, right? Easy. Okay. So let me erase that because I want to look at the answer in the right. All you have to do is find derivative by using quotient rule, and then let numerator equal to 0 to solve for the critical number. Then compare with two endpoints. This is number 9. Okay, number 9. See? The global maximum appears in the what? Occurs at the right endpoint, right? To fifth. The global minimum is obtained at what? At inside. Negative 1/3 is inside, right? The interior point is negative, the value will be negative 9/2. Okay, so we have found the answer. Right. Negative 1/3 is inside interval negative 2, 2, right? So this will, at the negative 1/3, the function will achieve what? Will have the global minimum, right? So this is negative 9/2, right? So here, the global maximum occurs at the right endpoint. The global minimum occurs at the interior point, negative 1/3. Look at your notes. We have found one value, negative 1/3, right? So this is what? Global minimum point. The global minimum value is negative 9/2. Okay? So global maximum value is 2/5, attained at 2. Global minimum value is negative 9/2, attained at negative 1/3. Okay? So remember we have two rules, right? Negative 1/3, we have to what? We have to keep, because negative 1/3 is inside negative 2. But another zero is 3. 3 is outside the interval, right? So we don't have to worry about that. Okay, we don't have to. Okay, so let's do another problem. So we have finished number 9, right? Let's do number 10. Okay, do number 10. Okay, to number 10. Find all values C satisfying the conclusion of the mean value theorem for this function. 2x squared minus x plus 1 on 2. So what's the mean value function? This, right? That's the conclusion of the mean value theorem. There's a C inside the interval such that f prime C is equal to FB minus FA over B minus A. That's the famous mean value theorem, right? So C always exists between two endpoints, A, B, right? Such that you have this. Okay? So for this function is a polynomial function, quadratic polynomial. So continuous everywhere, differentiable everywhere, right? So C always exists. Okay? Always exists. So what's F prime? F prime is 4x minus 3. So F prime C is 4C minus. Right? Because F prime X is 4x minus 3. So F prime C will be 4C minus 3. What's FD? For two inside to evaluate. What's FD? Please find it. What's F2 here? FD means F2, right? What's F2 here? This is 8 minus 6, 2 plus 1 and 3, right? So this is 3. Minus what's FA? FA is A0, which is 1, right? Over B minus A. B minus A, 2 minus 0. Okay, so what's the answer? 3 minus 1, 2, 2 is 1. Now solve for C. Plus 3, right? This is 4, so C equal to 1. Okay, so C equal to 1. So we have found this value C, right? Satisfying the conclusion of the MVT, the mean value theorem. So C equal to 1, we have found C 1 is inside this domain, 2 interval, right? So we have found the answer for this problem. So C equal to 1, okay? So this is very easy, right? You have just to use what? The mean value theorem, okay? Mean value. Let's look at number 10. right? The answer. C is equal to 1, right? It's equal to 1. Okay, it's equal to 1. We have found. Now let's do number 11. How can we find number 11? How can we solve for number 11?
Solve for the
How
second
can we solve
derivative.
it? Yes, you are right, William. You have a function in sin plus cosine plus 2, right? You have to find all intervals in 0 to 2 pi where f is concave up. You don't have to draw the concave down, only concave up, and identify all inflection points, right? You have to, as William said, you have to find the second order, right? Second order. So let's find it. Okay? So what's the first order? We're doing this problem, okay? What's the first order? Tell me what's the first order? Fx is x plus cosine 2. So what's the derivative here? Tell me, what's the answer?
Cosine x
What's the
minus
answer?
sine of x.
What's f? Yes, thank you. 2 is derivative 0. All right, sine derivative cosine, cosine derivative negative sine. You have to find second order, right? Please find it, everybody, with second order. You have to find the derivative of the first order. So what's the answer? Tell me the answer. What's the cosine derivative?
Negative sign.
Negative sign, right? Right. Minus sine derivative is cosine. Okay?
Yep.
Okay, so let that equal to 0. So for all the inflection points, right? And equal to 0 first. So for all the inflection points. So please solve it. What's the inflection points here? X must be inside the domain, okay? 0 to pi. Okay, domain is from 0 to pi. So find all the possible inflection points for this problem. So what does it mean? This is sin x equal to negative cosine x, or tan x equal to negative 1, right? So here you have right? Shift sin x to the right side divided by cosine x, right? Then tan x equal to negative 1. Okay, negative 1. Right? Because this sin x equal to negative cosine x, right? Or this cosine x equal to negative sin x divided by cosine x. Okay, sin over cosine sine tan, so tan x equal to negative 1. So what's x? Please find out what's x. Please find the two special values inside 0 to pi. If tan x equal to negative 1, what's that? What's the x here? This x must be in the what? In the second quadrant, right? Which is 3 pi over 4. Or in the fourth quadrant, right? Which is, what's fourth quadrant here? No. Yeah. No, change x equal to negative 1. Yeah, this is in second and fourth. What's the answer for the fourth? 7 pi over what? Right? So two answers for change x equal to next one. One is in the second quadrant, 3 pi over 4. The other is in the fourth quadrant, 7 pi over 4. Right? Now you can see how to determine. Right? From 0 to 2 pi. Okay, now 3 pi over 4. And this is pi. So 3 pi over 4 is right here, right? This is 3 pi over 4, right? Seven pi over 4 is right here. Okay? Right? 7 pi over 4. Okay, 7 pi over 4. Now you have to evaluate the sign for f double prime. Right? You pick any number inside, okay, to determine the sign. For example, you pick a pi half, right? Pi half, put the sign for this function. Okay, for half. Cosine pi half will be 0, sin pi half will be 1, negative 1. So this is concave down, right? Concave down, see? Right? Concave down. Okay, concave down. Let me write down, is concave down, okay? Concave down. Okay? Now please find the answer for this part. From 3 pi over 4 to 7 pi over 4, you can pick a pi, right? So 7 pi will be 0, cosine pi will be negative 1, will be positive. So it's concave up. Okay, concave up. And you concave down again, you concave down. Okay, so for this function, we have found the answer, right? When it's concave up, in the middle, right? Middle. Right? So you have to find where it's concave up from 3 pi over 4 to 7 pi over 4. Okay, so this is the final answer. Right? You concave down, you concave down, you concave up. Okay, so the answer is where f is concave up, this is the 3.4 from 3.4 to 7 pi over 4. Okay, these are two inflection points, 3 pi over 7 pi over 4. Right? You can put this to evaluate the y value. Y value. Okay, so the answer is easy to understand, right? In 3 pi over 4, 7 pi over 4 is the y. That's the interval of concave up, right? Okay. Now let me erase this because this is straightforward. I hope you have copied it down. Okay, I hope you have copied it down. Please copy it down if you have not done so. Okay, because I will have to erase this in a few seconds. Okay, in a few seconds. Now I want to erase this. This is problem number 11, right? Let's look at number 11. What's number 11? Right here, see? The curve concaves up at 3 pi over 4 to 7 pi over 4. Same answer, right? You have two inflection points. 3 pi over 4, evaluate the y coordinate, right? And 7 pi over 4, evaluate the y coordinate. So you have these. Okay, you have same answer, right? You have to find, you have two inflection points, and between 3 pi over 4 to 7 pi over 4, the curve concaves up, right? So we have finished. Right? You see that answer, right? Answer. Now, graphing is easy, okay? Graph this function, right? Identifying where all intercepts, asymptotes, where f is increasing, decreasing, where f is concave or concave down, right? And all relative maximum, minimum value and inflection points, right? So the derivative is given. So you don't have to find derivative. The derivative has been given to you, right? So you have to use this information to sketch, right? So what's that? So let's take a look at sketch, okay? So all this problem is quite time consuming, right? But you can do it, okay? You can do it. So this is a picture, see? This is a picture. This is a picture, okay? Okay, this is a picture. Picture. You have this, you have vertical asymptote, right? This is x equal to -8, right? You have vertical asymptote, you have slant asymptote, right? So this is a picture. This is a global maximum, right? The global minimum, right? Right. Okay. So that you have to follow all these guidelines, right? To find all the possible inflection points, maximum local minimum points, and when it is increasing or decreasing, will concave down, right? It's very tedious, but you can do it. Okay, the answer is right here. Okay, answer right here. So you can see that graph is at right. Asymptote is y to x -8 is slant, right? X equal to -8 is vertical, right? And the intercepts and increasing on this interval and decreasing concave up on this interval, right? And the local maximum is this point, local maximum, right? And the local minimum is this point, and no inflection points. Okay, so you can do it by yourself. Okay, I don't want to waste time on that because this is so straightforward. All you have to do is to look at your answer, right? And you can figure out by yourself, right? How to find the local maximum, local minimum, we know how to find it, right? By using first order. Concave down, we know by finding out what? Second order, right? All this is standard, okay? Let's take a look at how many problems left. We have only a few problems left, right? Not too many, I hope. Number 12 is graph. So we have found number 16, right? Number 16 is, remember we did number 16 on Monday, right? It's the antiderivative. So we have number 13, number 14, number 13. We have 3 problems left. It's nice. Okay, now please solve this by yourself. Use L'Hopital's law to evaluate. Please solve it by yourself. Everybody, please find it. Find the answer. You got to finish one problem at least, right? You cannot just copy my answer without doing any of your own work. Now please find the limit by using L'Hopital's law. Please find it. You put 0 inside, you can see that this is 0 over 0. So it's indefinite, right? Please find the limit by using L'Hopital's law. Please find, everybody, please try your hand, okay, to find the answer by using L'Hopital's law. Okay, L'Hopital's law will appear on the final, okay? So you got to learn how to find it, right? You have to, at every step, you have to test whether or not it's indeterminate or not. If it's not indeterminate, you can find the answer right away, right? If it's indeterminate, you have to use L'Hopital's law to find the answer, okay? Okay, everybody, please try this problem. Okay, please try this problem. This is not hard at all. Much easier to handle. Okay. please try this. Do not wait. Okay? Please try the problem. Okay? Please try the problem. William Dickon, I cannot see you. Rebecca Wallen, Carson Hampton, Condor, Max Ho,
I'm here.
Guest, Daniel Zhao, Sincere, please please turn on your Zoom camera.
I'm here.
Please find the limit by using L'Hopital. Yeah, I know. Yeah, please find the limit by using L'Hopital rule.
Yeah, I just did.
Jeremy? Okay, very
Oh, you
good.
want me to tell you?
Jeremy, Carson. Yeah, show me the answer. What's the answer?
It's 1/2.
1/2. Okay. William has found the answer, which is 1/2. Okay. Everybody, please do it by yourself by using the L'Hopital rule to find the limit. It's 0 over 0, right? So you can use L'Hopital rule. Please tell me the answer. Okay. William's answer is 1/2. How about other people's answer? Same answer or not? Rebecca, what's your answer? Rebecca, what's your answer?
I got 1/2 as well.
Okay, thank you very much. How about Angela? What's your answer? Angela, what's your answer?
1/2. I got 1/2 as well.
What? 1/2. 1/2. Very good. Luco, what's your answer? Sandra.
Same thing.
Same thing. Very good. So the answer got to be 1/2, right? So let's see why is 1/2. Okay, by using famous L'Hopital rule, right? So let's take a look at the. Okay, this is first. You have to what? You have to test. This is 0 over 0, right? 0 over 0. Because you put 0 inside. E0 is 1. 1 minus 1 is 0. 2 times 0 is 0. So you can use L'Hopital rule. Otherwise, you cannot, right? You go to limit as x approaches 0. Now, 2x derivative 2. This is not quotient rule, okay? This is L'Hopital rule. You cannot use quotient rule here, right? And ex minus 1 derivative is ex minus 0, right? And ex. Okay, now you test again, put 0 inside. E0 is 1, right? And it's 1/2. Indeed. Okay, so the answer, right? Sometimes you may have to use L'Hopital rule more than once, right? Here you only use 1, you can find the answer. But for some other problems, you have to use L'Hopital rule twice or thrice. Even you may have to use 4 or 5 times, right? But for this problem, once will suffice, right? So answer 1/2. Okay? I'm very happy that everybody got the same answer, 1/2, right? So L'Hopital rule will appear on the final, okay? You got to remember. Don't get confused with what? With the quotient rule. They're totally different. Quotient rule is for you to find what? Derivative. L'Hopital rule is for you to find what? Limit, if this is 0 over 0 or infinity over infinity, right? Okay, let's do number 14. So number 13 is gone. Let's do number 14. Okay, use 2 iterations of Newton's method to estimate a solution to 4 decimal places of x5 minus 4 plus 4 equal to 0, starting with x1 equal to -2. This formula is right here. So you don't have to remember the formula. You don't have to memorize it, right? Formula is given by you. So it's so nice, right? So nice. You don't have to memorize it. So let's what? Here you have to use calculator, right? Calculator. This is fx, right? This is fx. Right? Fx. What's the derivative for x fifth. 5 what? Right? Negative 4x divided with negative 4. 4 divided with 0. So it's 5x fourth minus 4, right? Now you can what? You can get x2, right? You can get x2. So what's x2? Equal to x1 minus fx1, right, over f prime x1. By Newton's method, right? Newton's method. Now x1 is given, so x1 is negative 2, right? x1 is negative 2, it's given. You don't have to think twice. Now what's f x1? It's f negative 2. So evaluate this as negative 2. And f prime negative 2 is, right? So let me write down, okay? So that's equal to x1 is negative 2, right? Minus f x1 is negative 2. F prime x1 will be negative 2. Okay, so everybody should know how to use calculator to evaluate. Put the negative 2 inside, right? And f prime negative 2, put the negative 2 inside for f prime, right? Then you find the answer for x2. Then you go back to find what? x3, right? x3. You have to use 2 iterations. This is the first iteration. Now, this is the second one, right? Then you stop it here at x3. This is the second iteration, right? So by same formula is x2 minus fx2 over f prime x2. Okay, so now as long as you find x2, you put this inside, right? To find fx2 and f prime x2. Here you have to use calculator, right? And to 4 decimal places. Okay, so that's straightforward. Okay, this is the Newton's method. You got to learn how to handle Newton's method. Okay, by using this formula, right? You go back again. Hopefully, the answer will become nicer, right? So this is the answer. Okay, this is the answer. Okay, so you got to use a calculator, right? Otherwise, the calculation will be massive, right? So first, you start with x equal to negative 2, which is given. Then here, you can use your own x2, right? You solve, you get x2, you put it back here, you solve for x3. You put x3, you go back here to solve for x4. If you have x4, you go back here to solve for x5, right? This is so-called what? Iteration, right? It can go on forever, right? On forever. This is Newton's method. Okay, this method is so easy to remember, right? But the calculation may be long, right? You have to evaluate f negative 2 and f prime negative 2. This here you have to evaluate f x2 and f prime x2, right? The calculation will be long, but the idea number 15. Let me erase this, okay? This is so easy. Where's the mouse? Here. Okay, let's do last one. A box with an open top. What does it mean, open top? It means there's no top, right? It's open, right? With base has length twice its width. Need to have a volume of 10 cubic feet. What's next? I cannot see. Gives the dimension of the box with the least amount of material used. Round your answer to 3 decimal places. What does it mean, least amount of material? It means the area should be what? Area should be minimized, right? So you can sketch the box. Let's sketch the box. The box is so easy to sketch, right? Please learn how to sketch a box. Otherwise, people will laugh at you if you don't know how to sketch a box. See? Right? See? right? And then you do this, right? Here, here, right? Right? Then use dotted lines inside. You cannot see. Hmm? See, this is a nice box, right? Nice box. See, I have sketched the box. See, this is a nice box, right? Nice box. Open top, so there's no top here. You don't have to worry about top, right? Base has length twice width, so this is length, right? This is width. So if this is x, right? So this will be 2x, right? If x is width, then the length will be twice the width, right? So it will be 2x. Now suppose the height is y. Okay, the height for this box is y. So you can find what? The surface area, right? So what's the area for this surface? You have to minimize this area, right? The area of this surface. How many surfaces does this box have? 5, right? Because no top, open top, no top. So what's the area for the base? 2x times x, right? 2x squared. Okay, 2x squared. Because this is the area for the base, right? 2 times x. What's the area on the side? In x times y, you have 2 of them, right? 2xy. Right? 2xy. Plus, you have added on what? On the front as well as back, right? 2x, this is y, so 2xy, right? Times 2. Why times 2? Because you have the area for front as well as back, right? This is y to 2x. 2xy is the area for the front, the back is same, right? 2. Here is the side on the right side, xy. You have on the left side, 2xy. 2x squared is the area for the base, but you don't have top, right? You don't times 2, okay? So this is what? This is, simplify this, okay? So this is 2x squared plus you have 2xy plus this is 4xy, 6xy. Right? 2x squared. And this is 2xy times 2, 4xy plus 2xy, 6xy. So this area should be what? Should be minimized. Right? For the least amount of material should be, the area should be minimized. Okay, the area should be minimized. But we have 2 variables. We don't know how to minimize the function with 2 variables, right? But fortunately, we have these. Is the volume is given here. See? Right? The volume is 10 cubic feet. So what's the volume for this box? Base times width times height, right? So let me write down. The volume for this box is base, which is 2x, or length of the base, right? 2x times width times height. Right? 2x times x times y is the volume. So what's the volume here? 10, right? 10. You have x squared y, right? X times x squared y divided by 2, right? It's 5. Okay, now what's y? Y equal to 5 over x squared, right? Okay, y equal to 5 over x squared, right? Easy to understand, right? X squared y equal to 5, so y equal to 5 over x squared. Now put this inside, right? This is equal to 2x squared plus 6x. What's y? Y equal to this, right? Right, so function is 2x squared plus 6x, y is 5 over x squared. Simplify this function now is become single variable of x, right? 2x squared plus 30 over x. Okay, over x. Right? So 2x squared plus 6x. 6x times this cancel out x, right? So 30 over x. Now say this function is, we call this function is fx, a function of x alone, right? Now how can we minimize this function? You take the derivative less than or equal to 0, solve for x, right? So let's do it. What's f prime x? What's 2x squared derivative? $30. Right? You take the derivative from the order of possible critical numbers, right? 2x squared derivative, x squared derivative 2x, 4x. And 1 over x derivative is negative 1 over x squared. So less than or equal to 0. Solve for all the possible critical numbers. Easy to solve, right? So this is right here. 4x equal to 30 over x squared. Right. Put the x squared over, right? So you have 4x cubed. Something wrong. Ah, nothing. Right? 4x cubed equal to 30. Now divide by 4. Cancel 2, right? Is 7.5. Okay, so you get x cubed equal to 7.5, right? X cubed. This is x, okay, not v, x. Right? X cubed equal to 30 over 4. 30 over 4 is 13 over 2 is 75, right? Now you take a cubic root, solve for x. So what's x? How many 3 decimal places? So please use a calculator to find. Tell me what's x. What's 7.5 cubic root? Tell me the answer. I don't have calculator with me. What's 7.5 take the cubic root? Tell me the answer. Keep 3 decimal places. Tell me the answer. Everybody, please tell me the answer. What's the answer here?
1.957.
1.957.
1.957. Thank you very much. 1.957. Okay, so this is the width. Now you can find length. The length is 2x. So tell me the answer for length. 2 times this. Tell me the answer. What 2 times 1.957? What's the answer? What's the answer?
3.914.
What's 2 times this? What?
3.914.
What's the answer? 3.914.
914.
Yes?
Yeah, 914.
4. Thank you. This is the length. Now, how about height by using these, right? So height is 5 over x squared. So tell me the answer. Put the x inside to evaluate. What's 5? What's the height for this rectangular box? What's the height?
1.305.
1 point? 1 point what?
1.305.
305. They're in what? What's the unit here? Feet, right? So please, you have to write down unit. Feet. Feet. And this is also feet. Okay, so we have found that the length is 3.914 feet. The width is 1.957 feet. And the height for this rectangular box is 1.305 feet. Okay, so please copy it down, okay? Because you got to show your work. Without work, no work equals no credit. Don't forget that. Okay? This 7.7336 we have just finished. Right, let me verify the answer, okay? We have just finished everything. Let me verify the answer, okay? Please, this is 1.975 is the width, 2x is 3.9114 is the length, 1.305 feet is the height, okay? So please check it, let me verify the answer. This is the last one, right? Last problem. Number 16 so on and so forth has been done on Monday. Okay, we're done on Monday. Okay, so everything has been done. I'm very happy that we have finished this. See, right? Width is 1.957, length is 3.915. That's okay, 914, that's fine. Don't worry about that. And the height is 1.305. They are all in feet, right? Very good. So we have finished everything, right, for our final exam review. So nothing has been left hanging. Okay, now please, if you have any question, please let me know now. Otherwise, say your name. I will see you Monday from